So certain common household things are held together by ionic bonds. Table salt is held together by ionic bonds. Table salt has a chemical formula of NaCl. So all it is sodium chloride. When we look at how this works, so look at this bottom image. Sodium has one lonely electron in its outer shell. That does not make it happy, so it's pretty much willing to give that electron up to any other atom. Chlorine has this nice open space. It is missing one electron to have a full and complete outer shell, an outer orbital. So it'll be stable when that's full, just like sodium. If it loses that electron, moves down to that lower orbital that is completely full and stable. So sodium is going to get rid of that electron, and chlorine is going to pick it up very, very quickly. When sodium loses that electron, it now has more protons than it does electrons. That makes that atom an ion, a positive ion. So this is now a cation. When chlorine gains that electron, it now has more electrons than it does protons in the nucleus. So the negative now outnumbers the positive. It is now a negative charge. That makes it an anion. All an ionic bond is a positive ion and a negative ion sticking together like magnets. So when you put the two ends of a positive and negative magnet together, positive and negative end, or north and south, they stick together. That's exactly what's going to happen in an ionic bond. Positive ion, negative ion stick together because of those charges. When we look at typical ionic bonds, the ions will actually aggregate in this crystalline matrix. So things like salt form this stable crystalline matrix with a very, very exact geometry because of that arrangement of negative and positive ions. And they're going to orient themselves positive, negative, all the way throughout the entire crystal in a three-dimensional image or three-dimensional space. So this is what we call salt crystals.